Hello everyone, and welcome to part 4 of my game dev tutorial series. Last time we completed our dual stick controls. The left stick is being done with ASDW and the right stick is being done with the mouse. And now we are going to be adding the projectiles. In the last video, I wasn't sure whether I'd do projectiles and mobs in the same video, but I think this one's going to run pretty long just to begin with, so rather than making an hour-long video, I'm going to separate those out. So here's our goals. Main goal, fire projectiles. Seems simple enough. We're going to do a little bit of code cleanup. We're going to add the unit class in between basic 2D and hero class, and I'll explain more on that later. We are going to add a timer class. This is crucial to pretty much any kind of video game. And that's part of the reason this is going to run a little longer, is just because I want to talk about it a bit, and it's another very major engine class. We did inputs. Timers are key, and you'll see that we need them here, or need is maybe the wrong word, but they are extremely helpful here. We are going to assign globals, screen height, screen width, which we didn't do last time. I completely forgot to do it, but we'll get it put in. We are going to create the projectile class. We are going to have Fireball inherit from the projectile class. We are going to add what I call a pass object. It's actually a delegate in C#. And what a delegate is they do lots of different things. But the way I use them is they're essentially a way to call a function from a parent class. In C++, it would be a pointer to a function. Java didn't have anything that I could at least remember off the top of my head that fills this role. But anyway, they're semi-common throughout programming languages, and I love them. I use them a lot. I find that they make my code so much cleaner and so much more readable. So I use them, and I will show you how to get them working. They're wonderful. Let's see. Then we're going to add a list of projectiles to the world. We are going to loop that update and draw that update because it's a list, right? So we have to actually loop through it. And for those of you that aren't very comfortable with loops, I'll go through it. Don't worry. But for those of you who are, you might want to fast forward through that part just because it takes a little bit of time to explain those. And then lastly, we're going to have the hero create the projectiles, send them through our delegate that will put them into our loop. Okay? I know that's some arrows and crap, but it'll all make sense when it's done. Anyway, that will do for the instructions. Alrighty, well, let's jump right in. First things first, like I said, let's add up that unit class. We're gonna put it right here in world. We're gonna start by just copying our hero because it's so similar. Right now, it's gonna be a placeholder because we'll have mobs and heroes, which are both units, and they'll both do a lot of the things the same, but they are gonna be a little bit different. So we'll have our unit class. Let's jump in real fast there, where it says hero now. Make sure you're in the unit, because right now they look exactly the same. Make sure you're in unit. And just change these two things out and delete our input. That's all we're doing in this class. It was that simple. And then we have to jump into hero, and instead of inheriting from basic 2D, we're going to inherit from unit. And done. That was all of it. So I know that only took 5 seconds or whatever, but it's an important step to have because we are going to have different kinds of units. I then make a units folder, and then I put hero in it. Alright, so we have that done. We now need to height and width stuff real fast. Grab that code. This is another thing I just do so rarely. I'm going to paste it, copy paste it, and then I will make sure that I explain it real well. Okay, so for right now I'm going to keep this small. Normally, actually, I like to test my games in windowed mode, believe it or not, and I test it at these ratios. Right now I'm going to keep it small just so that it's easy to see, but we will be switching to this at a later date. So what this does, we set the height and width that we want, then we say graphics. Graphics is just a Monogame library file, and it's instantiated here. You don't use it very much. There's a couple things it does in 2D. In 3D, it does a lot of things. In 2D, it does very little. And so we set the preferred back buffer. The back buffer is essentially the screen. So preferred width of the screen, preferred height of the screen. We set them in, and then you must apply the changes. If you don't do this, it doesn't do anything. I remember years ago when I was doing this, one of the most frustrating things I came across was I had these 4 lines of code and not this one, and I was pulling my hair out. And I found some tutorials, and for whatever reason, this line was just always off the screen, or I didn't notice it, or whatever. It was a frustrating process, but that was years ago. So make sure you put this in, long story short, okay? The next thing we're going to do is we're going to add our timer class to the engine. So for me, right, MC, always MC. That's just how it goes. Take the prompt off because came from my test. Anyway, all right. So this is our wonderful timer class. I wrote this again. I don't know, in college. This one's so old. I can't even remember when I wrote it. It's not got everything that my one that I use for my games has in it, but it has everything we need for now, and we will add whatever it needs later. I just don't want to have it all in there and then have to confuse everybody. So, what does this thing do? Well, it's a time span. A time span is something that's in Monogame, and it essentially keeps track of how much time has passed or elapsed, it says. We need to know what millisecond we're at. And this is just so that we can make it fire right at the beginning if we wanted to. So that's all it is. Good to go, meaning, when I test it, it goes. You can name your bool whatever you want, but sometimes I name them weird things. All right, so there's just our constructor. It takes in an int, which is our milliseconds. And there's another one, like I said, that we can load that bool with a true, and then when we test it, it will fire right away. That can be helpful for when you load the game and you want to fire some updating string or thread or whatever it is that you need to run to get things going. Is it important for this tutorial? No, but I figured I'd explain it anyway. Just these are protected, so public. Like I said, I copy pasted this. I didn't have it all public. I could redo it, but it's not important. Global's GameTime. We don't have that yet. Let me jump in. Let's get that done. Here it is. It is just public static GameTime. Monogame again. Just a Monogame class. It keeps track of the time between frames, essentially, and GameTime. And then we need to jump into main, and we need to set this up. We do it in update so that it always has the very newest frame. So it's just global's GameTime, which is what we just created, equals GameTime, and GameTime it actually says it right there because it's right there, but it provides a snapshot of timing values. So it is super helpful. Like I said, it gives you the number of milliseconds since the last frame. So let's say it starts lagging. It keeps track of all that for you. So let's say you're running at 30 frames per second, and it should be 33 milliseconds per frame. But then you drop a frame. The next time it's going to come back with 66 milliseconds instead of 33 and throw everything off. So can you do that on your own? You absolutely can. It is just really nice for them to take care of that little thing, because if you mess that up, you're going to get some weird stuff happen in your games. So it's just best to use Microsoft's, and we'll move on from there. All right, back to my timer class. That's not it. There we go. Okay, so this is just updating the timer. Literally just takes the timer and adds the elapsed times to it. And then you have this one, which allows you to change the speed with which you are adding the elapsed time. So let's say you wanted to add a function that speeds up or slows down time. This is how you would do it. So if you give it a 2, it's going to go twice as fast. If you give it a 0.5, it's going to go half as fast. Add the timer. So this is usually just used if you are going to when you load the game. So let's say you have a timer. It's got a 30-second cooldown. You use the cooldown, waited 10 seconds, saved the game, and logged out. So you have a 20-second cooldown left. So when you load, you'll add that 10 seconds into your timer and keep going. That way now you've loaded the timer properly. You could also use it, let's say you have a ability, and if you get 3 crit strikes in a row, it reduces the cooldown of your other ability by 1 second. You could just add that second to the other timer, and that will effectively reduce the cooldown. Test. This is probably the very most important thing, other than keeping track of the time, is finding out if it's time to launch your whatever it is you're timing, right? So let's say if your milliseconds is greater than the milliseconds we want, or this good to go bool, which we talked about, then good to go is true. Then we run true. And then reset will always set good to go to false, just so you know. Reset in this version will subtract the amount of time for the timer. So let's say that you are timing an event and it's gone 80 seconds, but your event only can go every 60 seconds. If we just use reset, we'll still have 20 seconds left on our timer. That's useful in some cases, but it is not the normal thing to do. This is reset, but with a given value left over. And this is literally reset to 0, as it says. So this is what I use probably 95% of the time. But the other ones are useful in their individual instances. This is just returning XML for it to save it. We'll go through link and stuff like that later. I'm not going to go through it right now. Set timer is just to set it to begin with. Same thing here, except for we're setting it with instead of a timestamp, we're setting it with an end. It's normally a long, so it has to be casted along. Alright, so that is, in general, how timers work. We will be using this later, so, yay. Alright, what's next? We need to create our projectile class, and that is going to take the majority of this time. So, let me get that going. And we'll get started. Let's see. In gameplay, world, that's where we're going to start this. We're going to add a new projectile 2D. That's what I call it, because it's 2D. And 3D ones are similar, but they're not the same. So anything that's 2D, I just put a 2D at the end, so that way I can have a projectile 3D, and they're both not called projectile, and then causing issues. So projectile 2D is what I use. Alright, let's get this all set up. We're going to remove the extra namespace stuff. We're going to add our includes. We are going to put in the wonderful public sign here. Great. It is going to inherit from basic 2D because it draws itself. We are going to we're going to grab heroes constructor. Well, we need speed too, so we might as well grab that. And come over here because typing's not fun. Alright, so that takes care of the position, the dimensions, and the path. What it does not take care of is some things that we need as well. So, first of all, we need to know who the owner of this projectile is. Why, you might ask? Well, in the game that I am planning to do here, I don't want to be hit by my own projectiles. Plain and simple. If you don't know the owner of your projectile and you run into it, it would hit you, and I don't want that. So your own projectiles can't hit you, so what we're going to have here is we're going to have public unit, which is why we had to create unit, owner. Alright, so now we have an owner for it. That's great. We want to pass that in when we create it. Awesome. And we're going to come in here and put owner. Cool. And then for this game, or at least this base projectile, we're not going to actually have a target for the projectile. We're going to fire it in a direction, and if it happens to hit something, great. If not, it's going to dissipate after time. Okay. So in this case, we're going to have a vector 2 that we're firing at. That's how we're going to get the direction. And I'm even going to call this direction. Perfect. And lastly, we need to have a... Well, actually, I have two more things to do. Public bool done. So when the projectile is either past its time or it hits something and it needs to basically leave our screen, we're going to have a flag that tells us that, or a bool. You'll hear them called flags constantly in programming terms, so just realize that's what I mean when I say flag. And then we're going to have public MC timer, which we just created, and we're just going to call it timer. Now, we need to get our target. Now, in some games, this would be another unit. Let's say, think League of Legends, Rise, right? He has abilities where you literally pick the target and you can't miss. Versus skill shots from other characters. If you are passing in another unit as a target, you're essentially saying this is going to hit, or at least most likely hit. Versus if you're using a vector 2, you're probably doing more of a skill shot thing. In this game, we're looking at more skill shots, so we're going to put this in, and then I'm going to say target, and we'll move down. Alright, so done equals false because we don't want it to be done right away. We got owner in speed. Let's say, I don't know, 4 or 5. Let's go with 5 for now. Projectiles need to be faster than a character in general. Not all, they don't need to be. It makes most sense if a projectile is faster than you are. For instance, if you fire a gun or shoot a bow and arrow or throw a boomerang or any of these number of things, they're probably moving faster than a human does. So, because our human's moving at 2, let's just do 5 for now. Let's see, direction. This is going to be a tiny bit of math, and I'll try to explain it the best I can. Target's vector 2, and we're going to subtract the owner's. Well, we can use lowercase owner. Owner dot pose, so it's the position of the owner. Okay. What this does is this will give you, when you subtract a vector from another vector, it gives you a directional vector. Notice I called it direction. So that vector itself, when multiplied times speed, will give us where we're moving to. Now, there is one other thing we need to do to direction, and that's to normalize it. What normalizing does is it makes it of length 1. Now, that might be confusing, so I guess I should probably go over this real fast. Let's create a new. That's probably big enough for now. Okay. Let's see. We have a vector, right? And it's from, let's say, 0, 0, because we're going to make the math easier on ourselves. And it goes to 3, 2. Okay? The length of this vector is this, well, it's Pythagorean theorem to get it right. Or a distance vector, either one. But it is 9, 4, 13, square root of 13. I'm not going to simplify it further than that, but that's a lot more than 1. That is between 3 and 4. What we want is we want a vector of length 1. Why? Because we want speed 5 to mean something. And we don't want the further something is away from it, the faster it'll move. So we have 2 points, we have our character, and then we have some point. If the guy's way out here, maybe it's, 10, 10. Now our speed, when we multiply it times 5, moves faster. So we want to normalize it into a vector that only has a length of 1. And then when we multiply this times 5, it'll have a length of 5. Hopefully that makes sense. If you have any questions, just ask them in the comments. I'm happy to go through it. And you know what? I just realized I got a comment last time, and I completely forgot to do this. I apologize. He asked for me to raise the font size. I apologize. It's there now. I'll try to remember to do it more often. Makes it a little harder for me to see, but it'll help people see the game, the programming better. I apologize for not doing that earlier. And then lastly, we need to put in our timer. And our timer, I don't know, what, about a second or so? Let's see. So 60 frames per second, we're moving 5 units. That is 300 pixels is we're moving. That's not bad, but I think the width of our screen is like 800. So let's do 1200 milliseconds. So this is 1.2 seconds. That's what that is. And we'll move on from there. We'll see how that works. If we don't like it, we'll change it. Then we need to update or create our update. So public virtual void update. And then the reason we did virtual void is we're not actually going to be overriding basic 2D, and there's a reason for that. So we are going to use vector 2 offset, but in order to know if we hit something, we need to bring in a list of units in order to test it, collision. Now, you could test collision in the unit class with the projectiles also. That's perfectly fine. I do it this way because this class is much smaller by the end than the unit class is, and so keeping the code away from the unit class so that that class doesn't get even larger than it's already going to become is easy to read and easier to follow. Also, I do that with all of the things that are like created by unit but aren't unit itself, and that way I always know where I'm looking for the code. The interactions are almost always, if not always, on the thing interacting with unit as opposed to unit itself, and it does help. Trust me. A unit may be a couple thousand lines long in some programming, in some games. It won't be in this game, but it'll still be probably 500 or 600 lines of code, and that gets harder and harder to search through. So, all right. So we have our wonderful update. In update, first things first, we're going to take our position. We are going to add direction, which is our unit vector. Remember, 1 unit of distance, and we're going to multiply it times speed. As I said earlier, that is where it's going. Awesome. Our projectile will now move. Next, we're going to take our timer. We're going to update that timer. Then we are going to test that timer. Test. And if it finishes, then done equals true. Why? T-R-U-E. Why do we do that? Because remember, we want them to stop at some point. We do not want our projectiles going on forever, and then eventually you have thousands of them in your memory, and you're either overflowing your memory or you're lagging your processor, all because you didn't get rid of your projectiles. Even if they're not going to hit anything because they're so far away, so they're not actually having an effect on the way the game is, on the gameplay of the game, they will have an effect on your resources. Also, we want them to disappear because if you try to shoot from too far away, I want you to miss. Again, they're a skill shot, not a easy everything shot. The next thing we need to do is test for hitting something. We are not actually going to completely test, but we're going to create a placeholder function for it. So public virtual bool, and then I call it hit something usually. Some people might call it collision test. I'm asking it with a bool. Did I hit something? Right? Hit something true? Great. It hit something. Hit something false? It didn't hit something. I liked to think of it in English, even though you don't have to. Alright, so there's our units, and then we're just going to return false for now. So like I said, it's just a placeholder unit. This will never return true in any scenario, but I wanted to continue writing the code for this class, so we used a placeholder, and because we're not going to do mobs yet, we don't actually need that piece of code for this tutorial. So hit something, units, and then if it hits something, done equals true, which again, it can never get here. It can never get here, but we're setting it up so that we don't forget. In here, we would also do like reducing its health or killing the mob. Well, actually, we wouldn't. Well, we would tell the mob it's hit. The mob itself would decide whether it's dead or not, and then it would remove from its list if it was. Alright, anyway, there's that. And then we have draw, which I guess we don't really need because it's not going to do anything extra, but we are just going to say public override draw because we probably will add things in here. Potentially effects like trails off the back of a fireball or any number of things here. So this is our projectile class. Let me just build real fast, make sure that we're kosher and we don't have a list of errors to deal with later. Alright, sweet. Now, this is a generic projectile. You're never going to be firing a generic projectile, or you shouldn't. What we're going to do is we're going to add a folder for projectiles. And then we are going to add fireball. Let's see, what's the best way to add fireball? Let's probably just to copy projectile. Notice, I don't like to type, so I think of the class that's closest to the class I'm trying to create, if there is anything close to it, and then I just rename it and work from there. So, fireball, and copy that before you click off of it so that we can paste it here and here. All of this does not need to be there because we are going to inherit from projectile 2D. Sweet. And it needs owner and target here. All of this is already done for us. In the constructor of Projectile 2D, we are not needing anything here, but we do need to call base. We need to override it, actually. And then we need base dot update and then offset units. And then that's correct. We don't need this at all. Alright. So that we made quick work of that. Here's our changes that we need to do. Because we're using a fireball, we know what the art for fireball is. We don't need a variable for it. So that goes here. Remember I told you there'd be times when we want static variables. Because it's a fireball, we know what dimensions we want for it. Or we'll make the dimensions we want for it. So vector 2. Alright, in this case, maybe 2020? I don't know. That's at least something. It's smaller than our hero, but, you know, big enough. We'll see. That's probably fine. Here's the thing. We don't have the fireball added yet. So we'll come up in here, into our content. We're going to add a folder for projectiles. Great. And I have... It's going to pop it up right now. This is my wonderful fireball. You can see how awesome it is. It is the most awesome fireball ever, obviously. It looks a little bit actually like a orangey, reddy jellyfish. But that's about all I got. I told you, I'm not an artist. But it should go to show you that you shouldn't let art get in the way of making a game. Just make some crappy temp art that at least you'll understand what you're looking at. And then after you have a game, if it's a good game, you should somehow be able to come up with the money to pay an artist to, you know, skin it. basically. Yeah. Very rarely, if you have done all that work, are you going to be held up by a few $1,000s of getting art done for your game. And let me tell you this straight up. If you have a game and it's good, and you let people play test it, and then they enjoy it, spend the money, find an artist, go get somebody from college, something, work out a deal to where you can afford to do it, and get it skinned and get it put on Steam. Don't be shy about it. Put it up. Have fun. You never know. At the very least, you can be proud of yourself for putting out a game. Alright, so we put this in here. Content, copy of newer. Please don't forget to do that. I know I keep saying it every time, but just remember it. And then... Alright, so that's our fireball. Or at least it should be. I hope I typed everything correctly. And... yeah, good to go. We double check our prompt here. Make sure that I'm not forgetting too much. We got that. We got that. We get to do our delegates next. So, remember I mentioned I used 2 globals files. Well, we're going to add our second one, because this delegate, if you create in the globals, you have access to it everywhere. So, new item. I call this one Game Globals. Call it whatever you want, but that's what I call the globals that are specific to the game. We'll add it. We will grab our includes, as we so regularly do. And top-down shooter, this needs to be public because it's going to use globals. Now, we have yet to enter anything in between the namespace and our class, but we are going to do that right now in order to add this delegate. They are kind of functions that are outside of everything. Oh, you know what? This goes in the regular globals. The delegate call goes in here. I apologize. And great. So I'm actually going to put out 2 delegates real fast, and I'll explain what they do for us here. So they're actually going here. I apologize. All right. So pass object takes in an object. What's an object? Well, it's anything you want it to be. You can stuff anything into that slot, and that's why I use an object here. And it doesn't return anything. So you're essentially just saying, I want to pass something somewhere and call a function somewhere. That's what this is. And then this one is the same thing, except for it returns an object too. Now, let's say you want to return 20 objects. We'll just create a class that has the 20 objects inside and stuff it in here. So these are the only 2 you really should ever need when it comes to calling functions, because you can create a class and stuff as much in there as you want. And you can create a class and return as much as you want. So, yeah, these are wonderful, wonderful things. You'll see how they're used. It's pretty stinking amazing overall. Then we'll jump into game globals, and this is where we create our wonderful delegate, and it's pass projectile. So anything can create a projectile. We could have a rock that shoots out a projectile. We could have a unit create a projectile. We could have a building create a projectile. We could have the sky create lightning bolts. And we don't have to worry about whether they have access to passing projectiles to our screen or not. And the way we are going to do that now is we're going to go into World. We are going to create the function that we're going to call. So public virtual void. Let's see, add projectile. And then we need to bring in the projectile, and there we go. So I want you to notice it is function object variable, and then in here it is function, oh no, sorry, here, function object variable. Okay? So if you, for whatever reason, decided you really wanted to make this, I don't recommend it, but let's say you did. Now you have to pass in 2 objects into whatever function you're creating. So I'm going to remove that. But that is how that works. World, where did you go? There we go. All right, so we have that now, and in our setup of our world, so wherever a projectile can be used, we want to set this up here. So game globals dot pass projectile equals add projectile. Done. So now we have set pass projectile to this function. So anytime this is called, it actually calls this. Well, let's just let that set in for a second, and then we're going to go use it. So, we also need to create our list. Public list projectiles projectile 2D. There we go. Projectiles equals new list projectiles. You could instantiate this down there. For whatever reason with lists I never do. I always do them up there. Because I never want them to be null. That just, it's more testing you have to do. So when I create a list, almost always, I would say 99% of the time, I am instantiating them up in the variable creation area. You could take this part off, take from here to here, and put it right here, and it's the same thing. But I find myself forgetting that a lot, and then I get bugs, and then it costs me extra time for development, and I just don't anymore. I used to, and I just don't anymore. All right, so here we're gonna say projectiles dot add. So we're adding to the list. We need to cast it as a projectile 2D, and then it's just info. I can't type. All right. So whatever we pass in here, we're going to cast it as a projectile, and it's going to be added to projectiles. If you pass anything but a projectile into here, it will break. Don't do it. I'm not going to do any testing for it because I know I am not going to pass anything other than a projectile into add projectiles. If you wanted to test for this, you would have to write an if statement here. You would have to test for some variable that you have set up that denotes that that's some kind of projectile coming in. Because you'd have to test for fireball and bullet and lightning strike and whatever it is, shotgun shells, whatever it is you're passing in here. Again, everything I pass in here is going to be a projectile. I don't need to test for it. I know that for a fact. So just be careful when you do it. I've warned you. I've told you. All right, so we need to update our projectiles. This is our for loop like I talked about. So in a for loop, you have 3 parts in your statement. So you have the variable for which you are incrementing. So in this case, int I equals 0. I for iteration. If you double loop, you'll use J and then K and then L, M, N, or whatever you want to use. But those, I just keep going down the list. If you get to pass about 3 loops, you're probably doing something wrong, almost always. But just keep that in mind. So we're going to continue this loop for I is less than projectiles.count. So however many projectiles there are, we want to loop through them all. Since I is 0 and count is 1 after we add 1 projectile, 0 is less than 1, so it runs. Next, we're going to say I plus plus. So this happens after the loop. And then I will be 1, so 1 is not less than 1, and so we would have run the loop 1 time. If there were 10 things in here, it'll run 10 times like this. This is the standard setup for a for loop. You can change this out to whatever you need to do, and you can increment by more than 1 if you want to. This is the vast majority of for loops. I will not use for eaches. You will not see me use for eaches. I despise for eaches. Every time I write one, I end up changing it to a for loop because I end up wanting to do more with the loop than whatever it is that the for each wants me to do. If you like for eaches, have fun. Go for it. I don't care. but you're not going to see me do it. So yeah. So let's go over this again. This is the increment for the for loop. This is the if statement, and when it returns false, we exit the loop. So we come down to here. Okay? And this is what happens when we get to the bottom of the loop and we start again. So we increment I by 1. So I equals 0, we check the first projectile. I equals 1, second projectile. I equals 2, third projectile. So on and so forth until we're done. So in here we're going to say projectiles I dot update, and let's see, we need an units and the offset. Okay, we don't have a list of units, so for right now, null. We're actually not ever going to have a list of quote-unquote unit. We're going to have a list of mobs, which we'll create next time. And then we need to create an offset here. Public vector 2 offset. As a placeholder, we are going to start scrolling the screen at some point soon. So I'm going to put this in now so we can start doing the placeholders for it. New vector 2 0 0. Okay, so the offset's not doing anything, but we have it. So this is updating all of our projectiles. Now when we come down in here, we need to do the same thing. The only difference is we don't need to pass in the list of units, and we don't need to update, we need to draw. Now I'm going to tell you this right now. What I just did by copy and pasting, if you do it the reverse way, if you copy and paste the draw up into the update and leave it as draw, it will break your game because you're not in a sprite batch begin and end segment. Okay, so you're not within this setup. Sprite batch begin, sprite batch end. We talked about it at the beginning, the very first tutorial. I'm just letting you know you're going to get a weird error. It's going to tell you something about sprite batch, and that's what it means, is that you're not there. And if you do it the other way, so if you do update down to here and don't switch this to draw, you just won't draw anything. You'll update it twice. Not a big deal, but it can be confusing. You're like, where is my projectiles? Why are they not drawing? Oh, that's right. I called update twice instead of draw once and update once. Alright, so that's that. We have our projectiles updating. We have them drawing. Alright, I almost forgot to add this. I'm going to jump this in real quick. We also need to make sure we remove the projectiles. So, if projectile I dot done, then projectiles dot remove at I, so that's just the location in the list, and then we need to decrement I, because otherwise you will miss a projectile updating this turn. It's a minor thing, but you need to do it. Also, if let's say you wrote code down here that was dealing with projectile I would break if it's the very last thing in the list, because it would overflow. Alright, that'll take care of that. Let's check our prompt. Let's see, we have fireball. We did our delegate. We haven't called it yet. We have added our loops. Great. Now, all we have to do is create the projectile on click. In Hero, so this is our wonderful input that we have here. Just go to the bottom, and we'll say if globals.mouse.left click. So, as soon as mouse gets clicked, we are going to create ourselves a projectile. So we're going to say game globals dot pass projectile. So remember, that's going to call world. Let me put that over there. World add projectile. So we're calling this right here. And we are going to say new fireball. The position will be that of our hero to start with. And eventually we'll probably move this to where it goes over their hand or whatever. But for now, we're gonna put it here. So we're just going to make it easy on ourselves and say position. Oh, hold on. New vector 2. Pose.x. Pose.y. Now, before I told you that you need to get used to doing it this way, if you pass position into Fireball, the hero's position, and you update the Fireball, the hero will move. And that is because it would be using... It would be looking at the exact same memory locations for position X and position Y. And so when you update them, you're updating the same exact memory. And therefore, you have now combined the position of both your projectile and your hero. You don't want to do that. You need to make sure you create a new vector 2. That's why I told you I wanted you guys to get used to it. The owner is this, right? This just means literally this class. Whoever made it, that's the owner of it. And then the target is new vector 2, and it is our mouse cursor. So globals.mouse.new pose, there we go, .x. And we will copy paste that. And it's Y. Alright, now this should... Ooh, we have a brokenness. What did I do? We have that one. We have that one. We need one more parenthesis. Whoops. There we go. Alright. This should work. Let's see what happens. Hopefully I didn't break anything. Alright, it loaded. Remember, we can turn around, we can move, and now we can click. And then the faster you click, that's about as fast as I can click, the more fireballs you'll have. Oh, you know what we didn't do? We didn't rotate our projectiles. Look, they all look like face-up jellyfish. We need to rotate them. Whoops. Alright, so let's look at Projectile 2D. And let's rotate them towards where they're going, right? Let's do that. Oh my gosh. This whole time, the text was smaller everywhere except for right here. I apologize for that. I need to do that for every single file. As you can tell, I don't change the font size hardly ever. But anyway, let's do our rotation. So rotation, we could do probably just the once because it's going to go straight. So yeah, let's do rotation equals globals.rotate towards, and then position, and then vector 2, close it up. I will be more careful about my text sizes. In fact, I'll probably go through every file when I'm done and make sure that my text sizes are bigger. Again, I'm sorry. I know I said I'd do it. I tried to do it about halfway through. I didn't realize that it was only going to be for one file. Been doing this for so long and I didn't even know that. It's pretty pathetic. But fact of the matter is, I have good eyesight, so I leave it at the one size, and I just never change it. So, anyway, let's build this sucker. Now our little jellyfish fireball things should turn. Yeah, see, look. Now they're going different directions. That's better. That's what we want. Much better. Alright, so we've done that. It kind of looks like he's breathing fire. That's fine. And then next tutorial, what we'll do is we will add things to shoot. This has already been an incredibly long episode. I apologize for the length, but I didn't know how else to break it down than what I did. So anyway, next we will create spawn points, we will spawn mobs, and we will make projectiles hit the mobs. That is what's on tap for the next video. If you enjoyed the video, make sure you subscribe so that YouTube knows you want to see the rest. Hit like so that YouTube will show it to other people, because you know it's not maybe a garbage video, maybe it is, maybe you don't like it, you know, but if you do, hit like and then other people will see it. And if you really want notified about new videos that I put out, hit that notification bell as well. And check on Twitter or Facebook if you feel like it. Past that, guys, thank you so much for watching this. I'm sorry that it went so long. I hope that none of the tutorials are ever this long again. But that is what I had today, and I had to get all this put in together in order to make this happen. Yeah. Have a good one, and I will get you, hopefully, another tutorial. I'm hoping Friday, unless something happens weird in my life. I will get you another one out on Friday that happens to shoot the mobs. Okay? Alright, have a good one. Bye.